Image formation by plane mirror. When we look into the mirror and see ourselves, we know that the image formed is erect and naturally inverted. But why? 2.4 Formation of point image and method of no parallels. In the next physics lesson, you are going to do an experiment to see how a plane mirror may form an image, and you will see why the image formed by a plane mirror is laterally inverted, that is, left side right. So, in this experiment, you are going to direct a ray of light to the plane mirror again, just like last time. But this time, you are going to direct a second ray of light and see how this second ray of light is reflected by the mirror. And in this way, the reflected light rays will seem to come from a point behind the mirror. And we call that point behind the mirror image, because the reflected light rays seems to come from this point. There will be two important conclusions from this experiment. 1. The line joining the object O and the image I will be perpendicular to the mirror, which is MN, so that OI perpendicular to MN. Second, the object's distance U will be equal to the image distance V, so U equals V. When you have finished your own experiment, your teacher will be pleased to show you another way to locate the image. This is called no parallels method. So what are the uses of the two conclusions just now we mentioned? Let's now try question 21. So for part 1, this dot represents an object. So the line joining the object to the mirror should be perpendicular, and this is the object's distance. And for the image, it should also have a line that joins with the object O, so that the red line is perpendicular to the mirror. And the image distance, which is the length of the red line on the right, should be the same as the object's distance, the length of the red line on the left. And so the image is here on the right hand side. And in this way, you can see that the line joining the object and the image, which is OI, will be perpendicular to the mirror MN. Secondly, the object distance U would be the same as the image distance V. So, can you also show me how you may find the image for the second diagram on the right hand side if the green dot here represents an object? Next, we will draw incident ray from the object and the reflected ray to the observer eye. What does that mean? We are going to draw an incident ray from the object that fall onto the mirror, and that incident ray will be reflected to the observer eye, just like that. By the way, do not forget to draw arrows to show the direction of the light rays. And you should draw two light rays from the object striking the mirror, reflected. So in this case, I draw it one blue and I draw it another red. Now part C, it asks you to produce the reflected ray backwards and draw the virtual rays. What does that mean? That means you should draw dotted line light rays backward so that you can see the dotted line intersect at a point, which is the image. (2.5) Nature of image formed by plane mirror. Extended object. Extended object is an object that has a size. For example, the diagram here shows an object AB. It has a length AB, and so the image of the object would also have a length A dash B dash. So how to find the image of an extended object? Let me show you here. First, we should find the image of one of the ends. For example, A. We find the image A' on the left. Similarly, for B, we may also find its image B'. In that way, for the whole object AB, then its image should be A', B'. Easy, right? Similarly, if you have a more complicated object, you can also locate the images of different points of the object, and in that way, you may find the image of the whole object. As you can see, that the images formed by plane mirror are always erect and naturally inverted. By the way, the image can never be projected onto a screen. That kind of image is called virtual image. And when you are drawing virtual rays, they should be drawn with dotted lines, just like what we have showed you above. For question 24, Peter stands in front of a mirror, and let's try to find the image of Peter behind the mirror. So there are light rays from his shoes and also from his head strike on the mirror and to be reflected to his eyes. And his image will be formed on the right hand side like this, at the same distance from the mirror as Peter is in front of the mirror. And so you can see the mirror need not be too long. It can just be of this length, and that will be enough for Peter to see his own image.